First, we're going to start with scatter plots in Chapter 9. Now, I know that scatter plots are something that you're familiar with, something that you've encountered in your past math classes, but we're going to take a look at them again just to review, and then we're going to go to the next level and see what we can use to predict from scatter plots. So let's take a look at graphing. Hopefully we know how to do that. If not, go ahead, pause your video here and try graphing those points. I'll quick graph all of them so you can double check yourself, but if you feel good about graphing, feel free to move on. All right, hopefully we got all of those points because we are going to have to be able to graph to make a scatter plot. Now let's take a look here on how the weight and the circumference of a ball relate to one another. So go ahead and plot these points, and let's use an axis of scale of 2 ounces. Since the largest one I'm seeing right now is a basketball, and that's 21 ounces. So let's go by 2's down there on that x-axis. And then for circumference, let's go by 3's. Since the water polo ball here has a circumference of 27 inches and the soccer ball has a circumference of 28, that would allow us to get up to 30. So go ahead, label that graph, and then plot all of the points. All right, so my dots aren't perfect, but you get the idea. It's kind of hard to make dots on a graph on an iPad. But we can see overall what pattern's happening. Think about it. Don't just wait for me to give you the answer. Pause the video. Think about what's going on between the weight and the circumference. Did you notice as the weight increases in ounces, the circumference also increases? And we can kind of see that we have this positive relationship going on here. So as the weight goes up, the circumference is always going up. Now the dots aren't in a perfect line. That's what makes it a scatter plot. But it kind of looks like when we talked about linear functions. They almost are aligned. They're not quite. But the relationship overall follows that upward pattern. Now, that was part B. Number C, do you think it's a positive or negative relationship? Well, hopefully, since both variables are going up, we see that it's a positive relationship. And it's not exactly linear, but if we were to draw a line that models what's happening, that would be pretty close to a linear relationship. Now, it says a bowling ball has a weight of 225 ounces and a circumference of 27 inches. Let's back this up. Circumference of 27 inches would be along here. In 225, whoa, I would have to go over 10 times to the right. Definitely don't have enough room. So if you think about it, does that bowling ball really follow the pattern of this upward linear line or this positive linear line that we drew? No, not really. It would be way below the line. That's what we call an outlier. Now, can you think of another ball that would be an example that doesn't really fit with the model that we have on our graph? In years past, I've had kids say, like an exercise ball. You know, like the ones down in the weight room, they're really big because they have a really big circumference, but they don't really weigh a whole lot. They're really light, right? So think about some other balls that could possibly not fit exactly on this model. All right, for this next one, if you have graph paper, go ahead and graph these on graph paper, or I went online to Desmos and just typed in all of the ordered pairs, so 095, 388, etc. And then I took a screenshot of this. So for part B, it says, describe the relationship between the absences and the final grade. Let's take a look. So this is my absences are along the x-axis here. And then my y-axis are the grades. And you can see this is how I just typed them into Desmos. Now we can see that there's a relationship. It's not a perfect straight line, but it's approximately a line. It's not terrible, right? So as our absences increases or goes up, what's happening to the grades? They're falling, right? So for part B, the relationship between them, increased absences causes a decrease in grades. And then the second part of B says, how is this similar to the relationship between the weight and circumference in activity 1? Well, we don't have a perfect line, but it's a very close, or it models similarly to a linear relationship. And there is something going on between the two variables. Now, It's different, though, than that first one, because in the first one, it increased, right? As ounces increased, the circumference increased. Instead now, as the absences increase, our grades are decreasing. The next question, part C, says a student has been absent 6 days. Use this data to predict the student's final grade. So you can't see it on my screenshot, but I did just write the scale in yellow there. That stands for the number of days absent. So for 6 days absent, if we go up, approximately on our line, we would predict that their grade would be 80%. So we use that line to help us make that prediction. So scatter plots and other forms of data analysis allow us to make predictions about relationships that are happening. All right, so let's take a look at these 3 scenarios. Now there's 3 graphs that we need to match with it. Letter A says the month of birth and the birth weight for infants at a daycare. What do you think? Does it matter how much a kid weighs depending on what month they were born in? It might, right, with their age, because we'd expect a newborn or like a 1-month-old to be much lighter than a 12-month-old baby. Let's take a look at the other scenarios. Maybe that'll help us narrow it down. What about the quiz score and the test score of students in a class? What do you think? If you do pretty well on quizzes, do you usually do pretty well on tests? Or if you really bomb quizzes, do you usually bomb tests? Not saying all the time, but just in general. Now the last one, the age and the value of laptop computers. You know, you guys are into electronics. What happens as your devices get older? Maybe that one seems the most obvious for you. So C, let's focus on that. As your computer or your laptop gets older on the x-axis, what's happening to the price or the value of it? Probably going down. So I would say that third graph is the most appropriate for letter C. Now let's work our way back up. Quiz score and test score. Hopefully you were thinking, man, if I do good on a quiz, I'm probably going to do good on a test. That's usually how it goes. So as quiz score increases, our test score should also likely increase. Now, you might be thinking, that's not true all the time. You're right, it's not, which is why it's not perfectly a straight line. And then the last one, month of birth and birth weight for infants at a daycare. Think about it. After kids get to a certain age, maybe after they're 1 or so, does it matter what month they're born in and how much they weigh? Not necessarily. It's kind of all over the board. So then that would be, oops, I wrote down the wrong one on the last one. Okay, for B was letter I. It was that first graph. I wrote on the first graph, but then I wrote it down wrong. But for the birth weight, it might be all over the place, like in graph 2. So that's what we're going to say matches up with letter A. We're going to go ahead and pause here. If you want to work ahead through the rest of the scatterplot examples in lesson 9.1 notes, go for it. And then you can just check back in with the next video to make sure that you're doing it correctly.